This lesson is on extreme values of quadratic functions. We'll talk about extreme values toward the end of this lesson. At the beginning, I want us to explore a little bit more about quadratic functions. We're going to look at what we call the standard form of a quadratic function and review some of the things that we know about the graph and talk about the vertex of a quadratic function, and then we'll move from there to extreme values. Let's look at what we call the standard form of a quadratic function first. A quadratic function, f of x equals ax squared plus bx plus c, can be expressed in the form f of x equals a times the quantity x minus h squared plus k by completing the square. The graph of a quadratic function is a parabola with vertex at hk. The graph will open upward if a is greater than 0, and it will open downward if a is less than 0. Now, you might recall having looked at basic quadratic functions before. In fact, the most simple quadratic function that we can have is the function f of x equals just x squared. That would be where a is 1, b and c are both zeros. And of course, you know what that graph looks like. You've got your mental picture we've talked about before of that being a parabola with a vertex at 0, 0, and this graph, of course, opens upward. I want you to notice with this simple equation, we don't even have to complete the square to write it in this form. Notice that since I do not have anything subtracted from subtracted from x, it's like h is a 0. In other words, x subtract 0, quantity squared is just like x squared. And if I put a plus 0 here for k, this would simplify down to just f of x equals x squared. And of course, any coefficient that's not written is understood to be 1. So f of x equals x squared fits this form where a is 1, where h is 0, and k is 0. Notice this said what? That the graph is a parabola, which we have, vertex at hk. Well, in our case, h and k both being 0, says our vertex is at the origin. Notice the graph will open upward if a is greater than 1, or a is greater than 0. Our a is a 1, which obviously is greater than 0. Now, most equations are not this simple, and in order to get this format, we will probably complete the square. The important thing for us here is to remember that a quadratic function occurs when we have this x squared term here. This could be written a y instead of an f of x, but we have that x squared term. Our x is to the second power. So in our first few examples, we're going to be working on this standard form and identifying the vertex. We're also going to review in this process intercepts, and we're going to see if we can locate the vertex of our parabola and use intercepts. Then we'll be able to get a real quick sketch of our graph and know some things about it. This wants us to sketch the graph of the parabola, state the coordinates of the vertex, and find intercepts. Now, I want you to notice in this equation we have the x squared term and we have a constant term. We do not have x to the first power. So if I slide this back up here a second, that's like having ax squared and c, where b is 0. Now, if you do not have this term where you have x to the first power, it's not going to be necessary to complete the square. We can just simply identify our h and k, and if we don't have that x to the first power, I can tell you right now that your h is going to be 0. For instance, on this function, I can rewrite that it's this as 1/4 times the quantity x subtract 0 squared minus 2. Notice x subtract 0 squared is just like x squared, and so this equation is just like this one, but it has this form. Now, having put it in this form, I want to talk about us recognizing h and k. Notice in this form it says x subtract h. Now, what do we have subtracted from x? Here we have 0. So in this equation, h is 0. Now the other thing I want you to notice here though in this form is this says plus k. Now what I have here is a minus 2. Recall that I can rewrite a minus 2 as plus a negative. So I'm going to do that for emphasis here. 1/4 times x minus 0 squared plus a negative 2. And I'm just doing that to emphasize it says plus k. So I have to think about that to identify k here. K is negative 2. Okay? Now while we're looking at this, what is my a? As far as my standard form is concerned, my a is the 1/4, isn't it? Notice that my 1/4 is a positive number. It is greater than 0. So I know since a is positive, it's going to open upward. Now, having located this vertex by simply recognizing the form that this equation is in, my vertex is going to be at 0, -2. Remember, hk gives you your vertex point. So I'm going to locate 0, -2. Because my a is a positive quantity, I know that my graph is going to open upward from that vertex point. Okay? Now, because this problem specifically asked me to find intercepts, I'm going to do that to help me locate a couple of points here on the x-axis where my y value is 0, and that will help me to sketch in my graph. Notice that we already have the y-intercept. You can see here that our vertex is on the y-axis, and so that is our y-intercept. And obviously from this original equation, if x is 0, we get y equals -2. So that intercept is easy to find. Let me just go ahead and make note of that since it asked to state that. My y-intercept is at 0, -2. It's the same as my vertex point, as it turns out. That will not always be true, by the way. Now, remember, to find x-intercepts, we let y be 0, and in this problem, f of x, remember, is just a different symbol for y. So letting y be 0 is equivalent to letting f of x be 0. So I have 0 equals 1/4 x squared subtract 2, and we're going to solve this for x. Let's add 2 to both sides, giving us 2 equals 1/4 times x squared. We'll multiply both sides by 4. 4 times 2 is 8. 4 times 1/4 is 1x squared. And then at this point we can take square roots, and remember, when we take square roots we need to take both the positive and the negative. So my x value is plus or minus the square root of 8. Remember, we can simplify that as 2 times the square root of 2. Recall that process under that square root. I can think of 8 as 4 times 2. The square root of the 4 gives me my 2 right here. And then I have the square root of that other 2 listed there also. Now, I have a calculator here. You probably will not necessarily be able to see this, but I'm just going to do the square root of 8 here to give me an approximate value. That's about 2.8. I'm just going to get to the nearest tenth here. So I'm going to say approximately plus or minus 2.8. Okay, so my x-intercepts, if I have room to write these down here, my x-intercepts occur at plus or minus 2 square root 2, comma 0. Anytime, by the way, that we're stating intercepts, we should state the exact value. Now, I wanted to do this in terms of locating these points on my graph. So if 2 times the square root of 2 is about 2.8, I know that at about 2.80 and negative 2.80, I'm going to be crossing that x-axis. And notice then with these points, I can just sketch in a quick sketch of my parabola. So the key part here is the vertex is found by getting this standard form of our equation where we can read off the hk to identify our vertex. Finding intercepts, we let x be 0, and then we let y be 0. Okay, in this case, that's all we needed to get a quick sketch of our graph. This also wants us to sketch the graph and also, again, state coordinates of the vertex and find intercepts. Now, I'm going to take this equation and rewrite it a little bit over here. First of all, I'm going to put the x squared term first, so I'll need to write minus x squared, and then of course that's a plus 3 since there's no sign written in front of the 3. Do you see that we do not need to complete the square because there is not an x to the first power in this equation? I'm simply going to write this as minus the quantity x minus 0 squared, because that's the same thing as x squared, and then bring down the plus 3. Now remember it said x minus h, so my h is 0, but it says plus k, so k is a 3. Since h is 0 and k is 3, I know that my vertex is at the point 0, 3. Okay, so I'm going to locate the point 0, 3. Now, what direction does my vertex open? What is my a value in this standard form? What's in front of this x minus h quantity squared? It's a negative 1, isn't it? Since that is negative, I know that my parabola will open downward. Okay? Make a note here, opens downward. Now, again, we're asked for the intercepts. I already, notice again, have my y-intercept occurring whenever x is 0, y is 3. And you can see that again here. Let's get those x-intercepts by letting y be 0. 0 equals 3 minus x squared. So that gives me x squared equals 3. X will be plus or minus the square root of 3. And again, I'll do the square root of 3 on a calculator. That's approximately 1.7. So approximately plus or minus 1.7. My x-intercepts then occur at plus or minus square root 3, comma, 0. Those are located approximately at 1.7. So about 1.7 and negative 1.7. And I have my parabola opening downward here. Now obviously you could get some other points. You might notice here that whenever x is 1 or negative 1, y is going to be 2, and you'll see those points right here. But actually, in this case, he didn't ask us to be real specific with the graph. Anytime it says sketch, it doesn't mean you're going to have a perfect graph, but we have identified the key areas that he wanted us to find here. Now, with these two examples, we've not had to complete the square because our x to the first power term was missing. In this next example, we're going to see that we do have that x to the first power, and so we're going to need to complete the square to get our equation in that standard form. Again, we're looking for the vertex and the intercepts. Notice here, this is what I'm talking about. See that 8x term? Because of that, we will need to complete the square. Now, what I would like to do is to show you how I prefer to complete the square. And in fact, I'm going to show you two alternatives, and I don't really care which method you pick, as long as you understand one or the other of these and choose the one that feels most comfortable to you. First of all, on completing the square, it's necessary to group your x squared and your x term together, and any constant that's in the equation you want to leave off by itself. So I'm going to put a parenthesis and group 2x squared plus 8x. That plus 5 is outside the parenthesis then. Now here's where I want to show you two different techniques. They're really the same thing, but it's just looking at things a little bit differently. The first thing I'm going to do is anytime you have a constant over here that's not in this grouping, we're going to bring that over here with our y value. In other words, I'm going to subtract 5 from both sides and write this as y minus 5. And if I do that, then I don't have to have necessarily the parenthesis here, but I'm going to be thinking about completing a square, and I know that I need to have a coefficient of 1 in front of x squared in order to complete a square. Now, in this particular case, I do not want to divide everything by 2 to get a coefficient of 1 here, and the reason for that is that puts a coefficient of 1/2 in front of y, which if you go back and think about your standard form of your quadratic function, your standard form over here has f of x. That means like y. You'll notice it doesn't say anything about 1/2 y or 1/3 y or anything else. It's just a plain old y. So I want to try to leave that y with a 1 in front of it. So what I'm going to do instead of dividing is I'm going to take these two terms and factor 2 out. So that will give me 2 parentheses x squared plus 4x, and then I will leave some space here. Notice here, if I multiply this back out, I have my 2x squared plus 8x here, don't I? Okay? Now that I have a 1 in front of my x squared, we will complete the square. I want you to notice half of 4 is a 2. It's a positive 2. Remember, then we square that. If I square 2, I get 4. you'll notice where I'm putting this 4. It's inside the parenthesis with this other step. I'm making this a perfect square. But I want you to notice right here at this step, if I multiply this out, I have my 2x squared that I had up here. I have my 8x that I had up here. And then notice I have a plus 8. Okay? Now this 5, remember, is over here. What I've done is, to this side over here, I have added 8. Now remember, if you add something on one side of an equation, you need to add it on the other also. So I would need to put a plus 8 over here on this other side so that I've added 8 on both sides. The reason it's an 8 over here is because this 4, being inside my parenthesis, is multiplied times 2. Now, we're going to simplify over here on the left. Y minus 5 plus 8 is a y plus 3. You can bring down that 2 in a parenthesis, and this x squared plus 4x plus 4 should be x plus 2 quantity squared. Let's check that. X squared, 2x doubled is 4x, plus, or 2 squared is a 4. Okay? Now that we're here, we can just bring that 3 back over here on the other side. We can subtract 3 from both sides, and we now have our standard form for our parabola that we wanted. Now, this technique I like because most people really follow the idea that once you've subtracted that 5 over here, if you add something to the left, or to the right, rather, you have to add the same thing to the left, and so they have that idea of adding the same thing to both sides of the equation. I want to show you another way that accomplishes the same thing, but it just does it slightly different. What that does is it leaves everything over here on the right hand side. We do need to still factor the 2 out of these two terms. So the way this would look is I would factor out a 2. That gives me x squared plus 4x, leave space, and then just keep bringing down that plus 5 that's out there. Notice right here, 2x squared plus 8x plus 5 is the same equation I had to start with. So you always want to be sure that you've not changed your equation. Now, when you complete your square here, half of 4 is 2. If you square 2, you get a 4. I'm going to put that in right there. Notice again, this 4 is being multiplied by 2. So I have added 8 to the right-hand side of my equation. Instead of adding 8 to the left hand also to keep it equal, this time I'm going to subtract 8 from this side. Now let's look at this. Right now, if I multiply, I have 2x squared right here. I have 8x right here. I have a plus 8, but this minus 8 will cancel that out and make a 0, and I have the plus 5. So do you see, again, I have the same equation. So the idea here was if I add 8, I subtract 8 on the same side, that's like a 0, and so I really haven't changed the way that, or the value of this equation. So that's another way of doing this same process. Now, if this is the way we've done it, we'll bring down our y, we'll bring down our coefficient of 2 out here. This x squared plus 4x plus 4 should be x plus 2 squared, and again, we check that out and it is true. And notice plus 5 minus 8 is a negative 3. So you can see that the two forms are the same. Now, it really is up to you. If you prefer moving the constant, adding the same thing to both sides and finishing up, and then if you need to move that constant back over, or if you prefer working just on this one side where you do the opposite. If you add something, you subtract the same thing. The end result should be the same. And don't forget that any time throughout this process, if you remove parentheses and everything, it should simplify to this very same equation that we have up here. Okay? Now I'm going to let you sort of look at that a minute, and if you may want to pause your tape and look at the two methods and decide which way you really prefer completing the square on this parabola. Okay, well, I'm going to copy this up here where we have completed the square. We have y equals 2 times the quantity x plus 2 squared minus 3. And then with that information, let's identify our HK. Now let's be really careful. In fact, I think I'm going to put the standard form right under here. Y equals a times, remember it says x minus h squared, and it says plus k. So if our equation says x plus 2, we want it to say x minus. Remember how we did this with circles? Instead of saying x plus 2, I can say x minus a negative 2. And instead of saying minus 3, I can say plus a negative 3. Now, you always will not have to rewrite this as long as you can mentally think about doing this step. So I can see that h is a negative 2 and k is a negative 3. So my vertex is at the point negative 2, negative 3. Let's locate that vertex. Negative 2, negative 3 would be right here. Now, does my parabola open up or down? Just notice what our A is. A is 2, which is positive. That means we're going to be opening up from that point. Okay? Now, let's find these intercepts. Usually I go back to the original equation when I'm looking for the y-intercept, because in that form it's real simple to see. If we substitute a 0 for x, what's going to happen? If x is a 0, y is going to be a 5, isn't it? Okay, so I know that 0.05. Let's go ahead and locate it. 0, 5. Okay. Now we need to find the x-intercepts, and we find x-intercepts by letting y be 0. Now again, you sort of have a choice on this, on how you want to proceed. One would be to go to the original equation, let y be 0. 0 equals 2x squared plus 8x plus 5. And then if you can factor this equation, then you would do that. In this case, this is not going to factor, I'll tell you right offhand. If you can't factor, remember you can use the quadratic formula. Remember the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. So if we use the quadratic formula, the opposite of b is going to be a negative 8 plus or minus b squared is 64 minus 4 times the product of a and c. Well, 2 times 5 is 10. And all of this is divided by 2 times a. 2 times 2 is 4. Now let's simplify this. Negative 8. Let's see, I have 64 minus 40. Can you see that? 64 minus 40 here is going to be a 24 over 4. Well, let's see, 24 is 4 times 6, isn't it? So we can take the square root of the 4. Okay, let me slide this up. So I will have a negative 8 plus or minus. The square root of 4 is 2, and I'll have that 6 still under the radical over 4. And then I can do one more step. I can factor a 2 out. Negative 4 plus or minus the square root of 6 over 4. And then we can reduce, can't we? 2 will cancel now. And my final form, x equals negative 4 plus or minus the square root of 6 over 2. Now, that process you should already be familiar with. You've done that before. But it did take us a while, didn't it, to work through that. What I want to do here is to show you that there's another alternative that you might want to look at. I'm going to save this, and I'll bring this back up in a minute so we can compare our solutions. I want us to go to this standard form that we have our equation in right here. Y equals 2 times the quantity, x plus 2 squared, subtract 3. Now, if we let y be 0 in this equation, it's going to look like this, isn't it? Now, let me show you what you can do. Add 3 to both sides. Divide by 2 to get rid of that 2 right there. 3 halves equals the quantity x plus 2 squared. Take the square root, plus or minus the square root of 3 halves equals x plus 2. Now solve for x by subtracting 2. Minus 2 plus or minus, this is the square root of 3 over the square root of 2 equals x. You can put that over 1. You can rationalize this. Multiply by the square root of 2 over the square root of 2. Negative, I'm going to write that as 4 over 2 plus or minus the square root of 6 over 2, which can be simplified as negative 4 plus or minus square root 6, all divided by 2. Do you see how we did that? That's another way. And if you notice, we have exactly the same solution. So it really is up to you on which technique you prefer to come up with those exact values of the x-intercepts. Now I'm going to write on our paper here, x-intercepts are at -4 plus or minus the square root of 6 divided by 2, comma, 0. Those are the exact values. Now, if we're going to be graphing, of course, we want to approximate those values so we can locate them, don't we? So what I'm going to do is take my -4, I'm going to add the square root of 6, and then I'm going to divide that answer by 2. That gives me about -0.8 if I round off, okay? And then while I'm here, let's do our -4. This time we will subtract the square root of 6 and divide by 2. And that is approximately -3.2. So those are my approximate values for these x-intercepts. Okay, -0.8 is going to be approximately right in there. And -3.2, 1, 2, 3.2 would be about there. And so notice we've got our vertex here, we have our two intercepts here, and we have this intercept up here. So with that information, we can get a quick sketch of our parabola, can't we? Okay, I have another one of these that I want us to look at. Sketch the graph. Again, we're looking for vertex and intercepts. And you'll notice here our equation is y equals -3x squared plus 12x minus 10. And so we're going to proceed as we did before. We're going to complete the square. Notice with this x term in here, we're going to need to complete the square to find our vertex. Okay, so what I'm going to do is group -3x squared plus 12x, and I think I'm just going to leave that minus 10 over here for right now. I notice that my coefficient of x squared is not 1, so I'm going to factor out this -3. Now be real careful with your signs here. When you factor out -3, -3 factored out of a positive 12 is a -4x. And here's where you want to leave space, bring down that minus 10. Now let's double check. That's always a good idea. If I multiply, I have -3x squared. Notice plus 12x minus 10, so I know I'm okay. Right here, my equation's all right. Now I'm ready to complete my square since I have my 1. Half of -4 is -2. If I square -2, I get a positive 4. Now here's where you want to think. This 4 that I wrote right here is times this -3. So what I really did is put a -12 here. Okay, I've put a -12 on the right hand side of my equation. Since this is -12, I need a plus 12 so that that will cancel out. Now let's see if we're still okay. -3x squared plus 12x minus 12 plus 12 is 0 minus 10. So I'm still okay, aren't I? Okay. Now let's bring down our y equals, we'll bring down the -3. This should be x minus 2 quantity squared. Let's check it. X squared minus 2x doubled is minus 4x. If I square -2, I get plus 4, so we're okay. Minus 10 plus 12 is a plus 2. Okay? Did everybody follow that? Now remember, your other alternative is to move the 10 over here as a y plus 10, and then if you put a -12 over here, you'd put a -12 on the other side. When you simplify and move that back over, you should still end up with this same form right here. Okay? Now, let me recopy that up here. Y equals -3 times x minus 2 squared plus 2. Now, is that in our standard form? It is, isn't it? Exactly. X minus h, so h is 2, plus k. So k is also 2. So my vertex is going to be at 2, 2. Let's locate 2, 2. Notice my A is a negative. So what does that do? My graph will open downward. Okay? Now, let's look at our original equation. What happens if x is 0? Y is going to be what? minus 10. So my y-intercept, whenever x is 0, y is negative 10. Now I think that's going to be kind of down below here. If x is 0, 1, 2, 3, 4, 5, 6, 7, let me approximate 8, 9, 10. So that's going to be somewhere down in here, okay? Now, let's get our x-intercepts, okay? And I'm going to try that new method again. I'm going to start right here and let y be 0. I have negative 3, x minus 2 squared plus 2, okay? Now, I'm going to subtract the 2. My next step will be to divide by negative 3. Now, I'm going to suggest be real careful here. The negative 3's over here cancel. Notice on this other side, I get a positive 2/3 is x minus 2 squared. Okay? Take the square root, plus or minus. I'm going to go ahead and write that as square root 2 over square root 3 equals x minus 2. Okay? I'm going to add the 2 now over here, 2 plus or minus. If I rationalize this thing right here, I'm going to have square root 6 over 3 is x. Put 2 over 1. My common denominator is 3, isn't it? So if I multiply this by 3, I have 6 plus or minus the square root of 6 all over 3 for x. Remember, your other alternative is to go to the original equation, let y be 0, and use your quadratic formula. You should get exactly this same solution right here. Okay, let me put down then our x-intercepts. We had 6 plus or minus the square root of 6. This was all divided by 3, and y was 0. By the way, remember that I cannot cancel this 3 with this 6 because my numerator does not have a common factor of 6. I can't factor anything out up here, so that doesn't reduce. Now, I will use my calculator again. 6 plus the square root of 6, all of that divided by 3, is about 2.8. And then I will take 6 and subtract the square root of 6 and divide all of that by 3. And that is approximately 1.2. You'll notice here I'm simply rounding off to tenths because it's going to be just a location on a graph. Alright, I have 1.2 and 2.8. Okay? So you can see from your vertex you are coming down through this intercept, down to this intercept, and on this side you're coming down here. Okay? Now, one thing that I might comment on while we're on this example is to remember that parabolas have symmetry right through that vertex. And you can see when I located these intercepts that they are equidistant away from that center line of symmetry there. And that's something always good to check yourself with. I hope with these examples that we've looked at so far, you're getting an idea of what you need to do to get that equation in standard form by completing the square. You may want to go back and look at that first example where I did the completing the square two different ways and see which one you feel the most comfortable with. The idea is you've got to be successful to get that form exactly right and then be able to recognize your h and your k. And then we've had some practice with finding those intercepts. Let's look at another example. Sketch the graph of the parabola, state the coordinates of the vertex, and find the intercepts. Now, notice again, this does have our x to the first power. So we are going to need to complete the square, aren't we? Well, let's see. I'm going to proceed by grouping x squared and x like we've done before. Notice there's no constant. All I have is x squared plus x. This already has a 1 in front of it, so I'm ready to complete the square. My coefficient here is a 1. Remember, you take half of that, half of 1 is 1/2, and then you square that. That's a plus 1/4. And then either add 1/4 here, or remember if you'd rather subtract the 1/4 over here, just so remember when you simplify this, you're back to x squared plus x. Bring down our y. This should factor into x plus 1/2 squared. Let's check it out. X squared. 1/2 times x doubled is 1x. 1/2 squared is 1/4, so we're okay. bring down the minus 1/4. Okay? So let me write that up here. Y equals x plus 1/2 quantity squared minus 1/4. That's what we got when we completed the square here. Now, remember this should say x minus h. Since that's a plus 1/2, that's going to give you what? H is negative 1/2, isn't it? And plus k, what's k? Negative 1/4. Try to remember how to think about that without having to necessarily rewrite the equation every time like we did in that first example or two. X minus h, that's a plus sign, then h is negative, and plus k, okay? So my vertex is at the point negative 1/2, negative 1/4. Okay, negative 1/2, negative 1/4 is just going to be barely below the x-axis right in there, isn't it? Okay. All right. Well, this is easy to see. If x is 0, so is y. So my y-intercept, if x is 0, so is y, is the origin right there. Now that should give you a hint about a point right over here. Let me suggest on this one that you notice something about finding the y-intercepts that might be easier than what we've done before. If we let y be 0, 0 equals x squared plus x, what can you do over here? You can factor, can't you? Factor out an x times x plus 1. So either x equals 0 or x plus 1 equals 0, giving you x equals negative 1. So my x-intercepts occur at 0, 0, and negative 1, 0. That's right in there. So really with just those points, I'm going to sketch in just the part of my parabola right in there. Okay? Now in this next example, we're going to be asked a different question, but we're going to find that we can answer it sort of by some of the same processes that we've looked at up to this point. Find the domain and range of the function f of x equals 2 minus 6x minus 4x squared. Now, I've got a graph here, and the reason that I have that is because I'm going to have us do sort of a quick little sketch, and from the sketch we're going to talk about domain and range of this function. I'm going to rewrite this f of x as a y, and I'm going to rearrange this stuff. Minus 4x squared minus 6x. I'm going to group that, by the way, and I'm going to bring down the plus 2 outside of that. Now I'm going to go ahead and complete this square. Now remember, I need to get a 1 in front of x squared, so I'm going to need to factor out that negative 4. Okay? Now you may have to think about this a minute. If I factor a negative out of a negative, I get a positive. I know what that sign's going to be. How do you go about factoring a 4 out of a 6? Well, let me show you something that you can do here. Think about this for a second. 4 times 6 over 4 gives you 6. So 6 over 4 could go here, couldn't it? But you can reduce 6 over 4. 6 over 4 is 3 over 2. Okay, now I'm going to leave that there. Now let's check ourselves. Negative 4 times x squared is negative 4x squared. A negative times a positive is negative. What is 3 halves times 4? 4 times 3 halves. Put the 4 over 1. 2 cancels. 2 times 3 is 6. So in other words, if you're trying to factor something out of a number that doesn't really have that factor, take the number, put the factor you're trying to get out underneath, and then sometimes you can reduce that. So that tells us what this fraction is. I'm going to bring down the plus 2 here. Okay? Now that I have a 1 in front of that x squared, I'm ready to complete the square. I take half of this coefficient. Half of 3 halves, that means 1/2 times 3 halves, will be 3 over 4. That'll be a positive number there. If I square 3 over 4, I get a plus 9 over 16 that I'm going to add right in there. Now be careful. When I multiply this, I get a negative. So I'm subtracting something. That means I need to add over here, the opposite. 4 times 9 over 16, the 4 cancels with the 16 and leaves a 4, so that's going to be 9 over 4. So I need to add 9 over 4. Now again, let's check. I've got negative 4x squared. We've already checked this, negative 6x. This is a negative 9 over 4. There's the plus 9 over 4 to cancel it out, and my plus 2, so I'm okay. Bring down our y. Negative 4 times the quantity x plus 3/4 squared. Let's check that, x squared. 3/4 x doubled. Well, if I double 3/4, what do I have? I have 6/4, which reduces to 3/2. And if I square 3/4, I get 9/16. Now, this 2 we can think of as being over 1 and add these together. If you get a common denominator of 4, this is going to be what? 8 over 4 is 2, so 8/4 plus 9/4. 9 and 8 is 17/4. Now those are sort of weird numbers, but let's talk about our vertex. X minus h. H is negative 3/4. Plus k. K is positive 17/4. Let's locate that vertex. Negative 3/4. 17/4 is 4 and 1/4. 1, 2, 3, 4, and 1/4. My vertex is going to be somewhere along in there. Notice because of this, my parabola is going to open down, isn't it? I'm not really concerned about where, but I know it's down. Okay? Now, let's talk about domain and range. Domain, remember, refers to x values. What can x be? Well, either by looking at this equation or looking at this graph, x can take on any number. So my domain is all reals. But notice, this is the reason I wanted the graph. What about my range? Look at your graph. Range is y values. My y values are never larger than where this vertex point is. All my y values will be below that point, won't they? What was the y value at that vertex? It was 17/4. So I know my y values will be less than or equal 17/4. And I can know that range exactly because of the vertex of my parabola. Now at this point we have just concentrated on getting the equation of a parabola, which would be a quadratic equation, into that standard form, completing the square whenever we need to do that. Remember, you know you need to complete the square if you have that term in there that has x to the first power. And then once we have that standard form, we can identify the vertex of our parabola. By the coefficient in front of our x minus h part, we can know if our parabola opens up or down. Because of the unique properties of a parabola having that vertex point and either opening upward or downward from that point, it's easy for us to talk about extreme values of a quadratic function. Now, in the next part of our lesson, we're going to concentrate on extreme values. And so the first thing I want us to do is to look at a definition of what we mean when we talk about extreme values of a function. An extreme value of a function means either the largest value, and I've used the word maximum here, largest value or maximum value, or the smallest or minimum value of the function on a given interval. Recall that by value of the function, we are referring to the y value. The value of the function is the y value. We get the value of the function by putting in a certain x value. Now, in one of our problems that we did earlier, let me just slide this one back up here on the screen. We had a vertex of this parabola occurring at the point negative 1/2, negative 1/4, and our vertex, from our vertex, our graph opened upward, didn't it? Okay? Now, when this is talking about extreme values, it's talking about either the largest or the smallest y value. Okay, well, you look at your graph. If it's opening up from this vertex point, then this point is the lowest point on my graph. We refer to it as a minimum point. Okay, this is my lowest point. Now, at that minimum point, where does that occur? It occurs at this vertex. Now, this is the x value that I put into the function, and this is the y value that I get out of the function at that point. So this y value is my smallest y value. So I would say that the minimum value of this function is negative 1/4, the y value associated with that vertex point. So an extreme value, notice we use the word extreme to mean either a largest or smallest value. So that's sort of a generic term there. Largest can be referred to as minimum, and maximum, and smallest can be referred to as minimum. In this next problem, we're asked to find either the maximum or the minimum value of this given function. Well, now here's where I want you to do a little bit of thinking. Look at your function first of all. What do you recognize about this function? See that x squared right there? This is a quadratic function. If you have a quadratic function, you have a parabola. If you have a parabola, you have a vertex. And your parabola will either open up or down from that vertex. That means you will have a minimum or a maximum. Now what we're going to do is sort of like we did a while ago. We're going to locate where the vertex is by completing the square on this function. Now this is written with an f of x, and just because y is easier to write, I'm going to change it to a y as I complete the square. We're going to group the 2x squared and the 8x. Bring down the plus 3. I do not have a 1 in front of x squared, so I'm going to factor the 2 out of these two terms. So factoring out 2, I have x squared plus 4x, leave space, plus 3. Now let's check ourselves before we keep going. 2x squared, 8x plus 3. Our equation's okay, isn't it? I have a 1 here, so I'm ready to complete the square. Half of 4 is a 2. If I square 2, I get 4. Now notice by putting a 4 here, that's an 8, isn't it? 2x squared, 8x, this is a plus 8, so I need a minus 8 to offset it and make a 0, plus 3. I'm still okay now. Bring down your y, bring down your 2. This should factor into x plus 2 quantity squared. 3 minus 8 is a negative 5. Now let's talk about our vertex here. X minus h, what's h? It's negative 2, isn't it? Plus k, what's k? Negative 5. Does this open up or down? Look at your a. That's positive, so that tells me it opens up. I have a parabola that opens up from the point negative 2, negative 5. Now, I don't even really have to sketch the graph. I just need to know that. It opens up. So this is my low or minimum point. Now, this is the point. Don't confuse that with the minimum value. Remember, that's talking about y value there. What is my smallest y value? Well, my smallest or lowest y value is negative 5. So the minimum value of this function is negative 5. Now, sometimes they may ask you, where does this minimum value occur? Well, it occurs whenever x is negative 2. So the minimum value is negative 5. It occurs at, we say, x equals negative 2. Okay? So again, finding this minimum or maximum, if we have a parabola, it just involves finding that vertex, and we're working on this, completing the square to do that. Let's look at another one. Find the maximum or minimum value of this function. Well, we're going to proceed just like we did before. I notice it's a quadratic. Y equals, I'm going to group negative x squared plus 4x. Bring down my minus 4. Now be careful here. We've been saying that we need a 1 in front of x squared to complete the square. That needs to be a positive 1. You'll notice here I have 1, but it's negative 1. So that means I'm going to have to factor out negative 1 before I complete the square. So we're going to bring that negative out in front. Notice that's going to change that to a minus 4x in that parenthesis. Bring down your minus 4. I always think it's a good idea to check here. If you distribute, you have minus x squared plus 4x minus 4. Now we have that plus 1. Half of negative 4 is negative 2. If we square negative 2, we get a plus 4. Now be careful here. This 4 inside my parentheses is times this negative 1. If I remove parentheses, I have minus x squared plus 4x. This is a minus 4. I need plus 4 to make that a 0, and this minus 4 is the minus 4 that's up there. Now look at that and make sure you see all of this, okay? Let's bring down our negative. This should be x minus 2 squared. Check it out. And minus 4 plus 4 is 0. Now where is your vertex? x minus h, h is a 2, plus k, k is a 0. Now, what about this parabola? Does it open up or down? Look at that coefficient right there. It's negative 1. That says it's going to open down. So this parabola opens down. This vertex point has coordinates 2, 0. Now that means this time I have what we call a maximum point on that parabola because that's a high point. It's the biggest point. So I have a maximum value. Now again, that value refers to what? The y value. So the maximum value of this function is 0. My y value is 0. This occurs at x equals 2. Okay? One of the reasons that we wanted to be able to find this maximum and minimum value of a quadratic function is because sometimes we have problems in the real world that are looking for a maximum or a minimum. You think about in business, it's always good to maximize profits, isn't it? Or it might be good to maximize what we call revenue, income. What would we maybe want to minimize in the business world? If you're saying cost, that would be a good idea. There would be other things that in science that we might want the maximum volume of something, or in terms of manufacturing, we might want to be able to manufacture a box that would hold the most that we could hold with a certain amount of material. So there are a lot of problems dealing with maximum and minimum. And we're going to look at just 2 examples here. And of course, we're being very careful about the types of examples. Since we've only looked at quadratic functions, you're going to find that these examples involve quadratic functions, since we know how to do the maximum and minimum values. A computer company has found that the revenue from sales of its model AJ2 computer is a function of its price. The revenue function is R of x, that just stands for revenue, just like f of x, it's a function notation. R of x is negative 1/2 times p squared plus 2300p. Now p is this price. Notice it's a function of price. Look at our question. What price should the company charge to maximize revenue? And then it says, what is the maximum revenue? Okay? Now, look at your equation. What kind of an equation is this? I'm just going to change that r of x to a y for a second just to make it look a little bit easier. 1/2 p squared plus 2300p. Isn't that just a quadratic function, just like we've been dealing with? So we know that the graph of this thing is a parabola that will either open up or down. We're going to find the vertex of this. We're going to proceed the same way. Now I know these numbers look big, but we're going to proceed as before. Since this has p squared and p and no constant, I know that I just need to get a 1 in front of that p squared, so I'm going to factor out that negative 1/2 p squared. I know the negative is going to change that sign to a negative, and I'm factoring 1/2 out of 2300. Think about what that needs to be. Remember, whatever here times 1/2 has to be 2300. Do you see that that would be 4600p? Negative 1/2 p squared. A negative times a negative is positive. 1/2 times 4600 is 2300, isn't it? Okay? Now, I have a 1 in front of p squared, so I'm ready to complete the square. Now, I take half of this coefficient. Well, we already know what half of it is. It's 2300, but that needs to be a minus here. Minus 2300. Now, what do I do with this? I square it. Now, I'm going to go to my calculator to square that, since that's such a big number. 2300 squared. I don't know if I left enough room here. Let me put a plus sign. I'm going to write it sort of sideways. 529, and I have 4 zeros. So that's what? 5,290,000. Now let's think about what I need to do here. 1/2 times p squared. There's my minus 1/2 p squared. This times this is my plus 2300p. Negative 1/2 times this is going to be a negative, so I need to add to keep my 0. I need 1/2 of that 5,290,000, so I'm going to divide that by 2. That's going to give me a plus 2,645,000. Okay? Now again, keep in mind what we wanted. This is minus 1/2 p squared. Here's my plus 2300p. Minus 1/2 times this gives me the negative of this, so that would add to 0. Okay? Y equals minus 1/2. This should be p minus 2300 quantity squared plus the 2,645,000. Now I'll let you check this if you want to, that if you square this you do get this trinomial right up in here. Now let's look at what we have. Can you identify your vertex from this? Well, this is like x minus h, so h is 2300, and plus k, so my k is 2,645,000. So there's my vertex. Does this parabola open up or down? What does that say? Down, doesn't it? So is this vertex going to be a minimum or a maximum point? If my vertex point is here and I open down, that's a maximum point, isn't it? So my maximum point occurs right here. Now keep in mind, in this ordered pair, this number right here is with p. That's like x used to be. So here's p, and this number is going to be my revenue. Remember, we let y stand for revenue. So let's go back and answer the question. What price should the company charge to maximize revenue, and what is the maximum revenue? Well, the price to give the biggest revenue should be this $2,300 is the price of this computer, and the maximum revenue is this second number here. Maximum revenue is $2,645,000, and we can answer that question simply by finding the vertex of our parabola here. So you can see here how a simple model like this might be real beneficial to a manufacturing company to work with how to price their items. I have one other word problem that I want us to look at. This is a little bit different. If you have 5,000 feet of fencing material, what is the largest rectangular area you can enclose? Now the reason I said this is a little different is you'll notice here we do not have an equation given to us like we did in the last example. We're going to have to come up with our equation. But I think we can do that. This is not anything that we've not dealt with before in terms of the things that we need. We have 5,000 feet of fencing material. We want to make a rectangular area, okay? So let's just do a little picture. I want a rectangle area, and my fence is going to go all the way around the outside edge, right? So the fence of 5,000 feet is going to be the same thing as what? Perimeter, or distance around this rectangle. So perimeter of a rectangle, remember, if we call this length and width, perimeter is 2 times length plus 2 times width. So this 5,000 feet of fence is going to be our perimeter. Let's write that in. 5,000 is 2 times L plus 2 times W. Now I think while I'm here, I notice that I can simplify this equation a little bit. Everything's divisible by 2, isn't it? Let's divide through by 2. 5,000 divided by 2 is 2,500 equals 1L plus 1W. Okay, so I'm going to keep this equation here. That's one thing that I know has to be true. But let's go back to the problem here. I have 5,000 feet of fencing, which led me to this equation. What is the largest rectangular area? Now I wanted to kind of key in on those words right there. Largest area. I'm going to use our new word, maximum area is what I'm looking for. Okay? Now let's talk about how do I get area of a rectangle. Area of a rectangle is length times width, isn't it? Okay? What I want to do is to write this area equation so that it does not have 2 variables over here. So what I'm going to do is use this one. I'm going to solve this equation for W. 2,500 subtract L will equal W. And I'm going to take that and substitute up here. So area will equal length L. In place of W, I'm going to replace that with 2,500 minus L. Okay? Now let's multiply this out. I have 2,500 L minus L squared. Here's what I wanted to get to. I have an equation that I'm looking for the maximum of, and it only contains one variable, and you'll notice it's quadratic. I've got it to the second power. So what I'm going to do is rearrange this. A equals minus L squared plus 2,500 L, and I'm going to complete the square. Now remember, you need to factor out that negative. If you don't do that, you're going to have a problem. L squared minus 2,500 L, and I'm going to leave some space here. Now I need half of 2,500, so I'm going to divide 2,500 by 2. That is 1,250, so I'm going to put my minus 1,250 down here. Remember, we're going to square that. If I square that, I get a plus 1,562,500. I nearly didn't leave enough room there, did I? Okay, that's 1,562,500. Notice if I remove my parentheses, I have minus L squared. I have plus my 2,500 L. I have a minus this 1 million stuff, so I need to do what? Plus 1,562,500. I'll sort of write that down there. Okay, now let's see if we can rewrite this. I'm going to bring down my negative. This should be L minus 1,250 squared, and I'm going to bring down that plus 1,562,500. Okay? Where's my vertex? This is taking the place of x. So this is like x minus h. So h is 1,250 plus k. So my k is 1,562,500. Okay? Now, this is like x, which L took the place of x. This is like y, and A took the place of y. This is my vertex. Notice this coefficient, so it opens down, so that gives me a maximum point. What was the question? What is the largest area? Well, if this is your maximum point, which one of these represents area? It's this second number. So the maximum area is 1,562,500 square feet. That's the largest area that I can enclose with this amount of fencing. Now you may find some of these word problems are more challenging in terms of coming up with those equations you need to work with than it is to actually solve the equation once you have it. What you need to remember from this lesson, first of all, is the standard form of a quadratic function, y equals a times x minus h, quantity squared, plus k. If you have your equation in that form, hk gives you your vertex, a tells you whether your parabola will open up or down. And then in terms of applying that information, you can apply it to graphing where you locate your vertex. Then you might use intercepts to help you finish your graph. You can also apply it in terms of looking at domain and range. Or you can apply it in finding extreme values. Extreme values meaning either maximum or minimum values. If you have a parabola that opens up, then you have a low point on that graph, a minimum point. If you have a parabola that opens down, then you have a high point or a maximum point on that graph. I hope that this has helped you so that you understand better about quadratic functions.